Welcome to Chemistry with Dr. Lillard. Today, we will look at 4 simple comparisons to help you understand matter. Elements versus compounds, atoms versus molecules, pure samples versus mixtures, and homogeneous versus heterogeneous mixtures. But first, we should ask ourselves, what is matter? Matter is stuff, anything that has mass and occupies space. Elements versus compounds. How do we distinguish between them? An element has one chemical symbol. A compound has 2 or more symbols that make up its chemical formula, and this chemical formula indicates that the atoms of these elements are bonded together. We can find these chemical symbols on the periodic table. So let's practice. There are lots of examples presented in this video. You may want to pause the video for each one so you can try to figure them out for yourself before the answer is revealed. Is quartz an element or a compound? It's a compound because quartz, which is SiO2, consists of 2 elements which are represented by 2 chemical symbols. What about oxygen in the tanks of this diver? Oxygen is an element because it only has one chemical symbol. Even though there are 2 atoms of oxygen, as noted by the subscript 2, there is still only one symbol present, which makes it an element. Aluminum. Is it an element or a compound? It's an element. There's one chemical symbol. And finally, what about vitamin C? Vitamin C is a compound because its chemical formula has 3 chemical symbols for the 3 elements of carbon, hydrogen, and oxygen. Atoms versus molecules. How do we tell them apart? An atom is an element only and consists of one chemical symbol. A molecule can be an element if it has 2 atoms of one chemical symbol, such as our diatomic elements. Or a molecule can be a compound if there are 2 or more symbols in its chemical formula. A molecule requires that there are 2 or more atoms, which can be the same or different elements. Let's practice these. Is hydrogen an atom or a molecule? Hydrogen is a molecule because there are 2 atoms of the chemical symbol H. It's also an element, and we recognize H2 as one of our diatomics. What about diamond? Diamond is composed of atoms because there is only one atom of the chemical symbol carbon. And finally, caffeine. Is it an atom or a molecule? Caffeine is a molecule because its chemical formula contains 4 chemical symbols and a total of 24 atoms. To compare pure samples and mixtures, now we look at how many substances and how many phases are in the sample. A substance is either an element or a compound, and we've seen this already. A phase is a region of matter that has uniform properties. For example, it's possible to have 2 solid phases in a sample which have different chemical compositions. A pure sample contains either one element or one compound in a single phase. Here, table sugar is shown, which contains only the chemical compound sucrose. A mixture can consist of two or more substances in one or more phases. In these color powders, each one is a mixture. Color powders generally contain cornstarch, dye compounds, and sometimes ionic compounds or metals. A mixture can also be a single substance that exists in two or more phases. The example here shows ice, which is solid water, in a glass of liquid water. There is a single compound, H2O, but some of that water is a liquid and some of it is a solid. So let's practice. These can be a little confusing, so you want to be sure to follow the guidelines carefully as you make your determinations. A pure sample is one substance, one phase. A mixture has two or more substances or two or more phases. Is helium a pure sample or a mixture? Helium contains a single substance in one phase, so it is pure. Next we have perfume. Pure or mixture? Perfume is a mixture. It contains water in addition to several compounds blended to give a specific fragrance. How about seawater? Seawater is also a mixture containing water and lots of salts, ions, and elements. Finally, we have acetone nail polish remover. Pure or mixture? This is a pure compound. As you can see on the label, it is 100% acetone, so there is only that one compound present. However, keep in mind that most nail polish removers are actually mixtures, even some that contain acetone. We'll finish up this video by characterizing mixtures and separating them into the categories of homogeneous and heterogeneous. A homogeneous mixture contains two or more substances in one phase. The chemical composition is uniform because the substances are evenly distributed. This example of brewed tea has more than two substances, only one phase, which is a liquid, and a uniform chemical composition. In contrast, a heterogeneous mixture contains one or more substances in two or more phases. The chemical composition is not uniform because the substances are not evenly distributed. Roasted coffee beans make up a heterogeneous mixture. Different areas of a bean might be more roasted than other parts, which alters its chemical composition. As such, the compounds in this sample of coffee beans are not evenly distributed. As we get ready for our final practice, keep in mind the requirements about number of substances and number of phases. That's what you're looking for in order to figure these out. Let's start with a donut with sprinkles. Homogeneous or heterogeneous? A donut has more than one substance, ingredient, and it also has two or more phases, different regions of matter. The donut, the frosting, and the sprinkles all have different chemical compositions compared to one another. The chemical composition is not uniform, and the sample is heterogeneous. Next, we have air in this hot air balloon. Homogeneous or heterogeneous? Air is homogeneous. There are two or more substances, such as nitrogen, oxygen, argon, ozone, CO2, but all within a single phase. The composition is uniform. How about this sample of water and a red dye, as shown in the image? This one is heterogeneous. there is more than one substance, and there are two or more phases. If we simplify this example and ignore mixing and dilution, we can see that the water is one liquid phase and the dye is another. The composition is not uniform. And finally, we have matcha green tea powder, homogeneous or heterogeneous. This one is homogeneous. There are two or more substances, theanine, chlorophyll, etc., but there is only one solid phase, and the chemical composition is uniform. And that's it. I hope these examples have helped you to compare different types of matter. Try to approach these types of problems systematically, and I think you'll find it easier to figure these out when you're presented with a new example that you haven't seen before. See you next time.